The velocity of the particle moving in the positive direction of the x-axis varies as v equals alpha root x, where alpha is a positive constant. Assuming that at the moment t equal to 0, the particle was located at the point x equals 0, find the time dependence of the velocity and acceleration of the particle. The mean velocity of the particle averaged over the time that the particle takes to cover the first s meters of the path. So we are beginning with this question again using the definition, that is, we write v equals dx by dt, and this is written in terms of alpha root x. So from here I can write it as dx upon root x is equal to alpha dt, and we can integrate both sides. So on integration I obtain x to the power minus half plus 1 upon half is equal to alpha t. Now since the question is saying at t equal to 0 the particle is at x equal to 0, so I can say that at a certain time t the displacement is x, and we will get this equation in this form, that 2 root x equals alpha t, and from here I can write squaring the equation x equals alpha square t square by 4. So this is the time dependence equation for displacement, which we have alpha square t square by 4. Now from here I can write v equals dx by dt. So if I differentiate the equation of displacement as a function of time, we get alpha square by 4 and t square can be written as 2t. So we obtain this equation to be alpha square t by 2. And the value of acceleration can be written as dv by dt. We obtain it as alpha square by 2. So for the first problem, we are looking for the time dependence of the velocity and acceleration of the particle. So velocity is equal to alpha square t by 2, and acceleration is coming to be constant alpha square by 2 independent of time. Now the next part, the question is asking the mean velocity of the particle averaged over the time that the particle takes to cover the first s meters of the path. So if the question is asking first s meters of the path, so from this equation I can say that if the displacement is equal to s, so let us calculate the time taken to cover this distance, and from here we get t equals 2 root s by alpha. 2 root s by alpha is the time taken to cover the first s meters of the path. And hence if I write the value for average speed or average velocity, then I can write it as the total displacement by time taken. So we have calculated the time taken as 2 root s upon alpha. So if we substitute the value of time over here, 2 root s upon alpha, so we get something like this, alpha root s by 2. So the average value of velocity will become